Is decision tree robust to outliers? Yes. Outliers have absolutely minimal effect on decision trees because decision trees divide items by lines. So it does not differentiate how far is a point from those splitting lines. And for that reason, any decision tree based classifier or ensemble of classifiers are not influenced by outliers. So single trees like CART, C5, CHEID, etc. and also ensembles of trees, for example, XGBoost, random forest, gradient boosting, and bagging are all robust to outliers. Outliers literally don't matter to trees because what makes an outlier, that is, using the common meaning, is the distance from other data points. So outliers are far away, most often measured by Euclidean distance. And decision trees do not care about this distance. They only care if the data is on one side or the other side of a split. It doesn't matter at all how far from the split the data point is. In general, in decision trees, the nodes are defined by the sample proportions in each split zone and not by their absolute values. So take an example. If you had 5 sample data points and one of their features takes values like this 1, 2, 3, 4 and the fifth value is 1 million. In this case, you might choose a split point at x equal to 2.5. With that split point, the data points with values of 3, 4 and 1 million all go into the same bucket and their values are treated the same way. You could replace 1 million with something orders of magnitude bigger and it wouldn't matter, or you could change its value to just 5 and even in that case it wouldn't matter. This restricts how much influence the outlying point can have. Contrast this with linear regression, where bigger the data point gets, the more influence it will have on the entire model. However, I just want to point out some other perspective as well, that different implementation to choose split points of continuous variables exist, and some consider all possible split points, other consider only a percentiles. So in some poorly chosen situation, for example, dividing a range between min and max in equidistant split points, outliers might lead to a suboptimal split points even in the case of decision trees. But you really shouldn't encounter these scenarios in popular implementation. So overall, generally, as long as the sample is sufficiently large, the effects of outliers will tend to be suppressed. And the next question I want to discuss about decision tree, that do we need feature scaling for decision tree? And the answer is no. Tree-based algorithms are largely insensitive to feature size. The decision tree divides a node based on a property that enhances the node's homogeneity. This split on a feature is unaffected by other features, resulting in scaling invariance or the invariance to monotonic transformation of any feature input or independent variables. Decision trees make decisions by successively splitting the data based on feature values, creating branches and nodes that lead to different outcomes. The algorithm compares individual feature values rather than calculating distances or making assumptions about the distribution of the data. As a result, the relative scale of feature does not impact the tree's structure or performance. And so the algorithm doesn't favor features with larger scales, as it only considers the information gain or impurity reduction when choosing a splitting point. Also, there's a point of interpretability. Decision trees are known for their easy interpretability as they provide a clear representation of the decision-making process. Scaling features can make this interpretability less intuitive, as the raw feature values in their original units are more meaningful to human readers. To give an example, if you have a strictly positive variable and a non-stochastic decision tree which can be achieved by setting the same random seed, you will get the same predictions if you use, for example, a log transform on the variable, as long as you do it consistently to all the data. Now, we want to discuss an example of this situation. Suppose you have a dataset with two features, x1 and x2, and a binary target variable y. The dataset looks just like this that you see in the picture here. So a decision tree might make a split on feature x1 at a value of 2.5. Separating the dataset into two subsets, the split is based on the relative position of the data points along the x1 axis. Now let's apply a monotonic transformation to both features, and we will double the values of x1 and x2. The relative position of the data points along the x1 and x2 axes are still the same. The decision tree will now make a split at a value of 22.5 along the x1 axis. So note now that the split has been scaled accordingly after making it double, but the overall structure of the decision trees and the classification of the data points remains unchanged.